The universe is vast and ancient. Its mysteries have beckoned to us since the dawn of human curiosity, stretching our imaginations across the endless tapestry of stars. For centuries we've wondered, are we alone? Every civilization has looked up, searching for signs that someone, somewhere, might be looking back. On August 10, 2025, the James Webb Space Telescope captured something extraordinary. A faint, persistent glow from the night side of Proxima Centauri B, our closest exoplanetary neighbor. This was not just another data point, but a moment that electrified the scientific community. This isn't a random stellar flare or natural heat. The signal was steady, repeating, and unlike anything we've cataloged before. The data shows a concentrated pattern of light, eerily reminiscent of city lights seen from space. It's as if, across the void, another world is glowing in the darkness. Could this be the first evidence of a civilization beyond Earth? The possibility is both thrilling and humbling. Proxima Centauri B is over 25 trillion miles away, yet across that gulf, a signal has reached us. Not a radio message, but the unmistakable signature of artificial light in the darkness. The sheer distance makes this discovery even more astonishing. Scientists have spent months ruling out natural explanations: atmospheric phenomena, volcanic activity, reflective minerals. Every hypothesis has been tested, debated, and scrutinized. The light remains stubbornly artificial. Its pattern, intensity, and persistence defy what we know of natural processes. This discovery forces us to rethink our place in the cosmos. Suddenly, the question of whether we are alone feels less abstract, more urgent. We've moved from speculation to observation. The evidence is no longer just theoretical, it's tangible, recorded, and awaiting further confirmation. The implications are staggering, touching science, technology, and the very core of our understanding. Philosophy and culture are shaken as well, but caution is essential. We must not leap to conclusions, no matter how tempting. This isn't definitive proof, just the most compelling anomaly in astronomy's history. The scientific process demands patience and rigor. It's a breadcrumb, leading us toward what could be the greatest discovery of all time. Each new observation brings us closer to an answer. We stand on a precipice, the universe suddenly feeling less empty and infinitely more interesting. The night sky now holds new promise. The journey to understand this distant glimmer has just begun. New missions are being planned and telescopes are being re-aimed, and it may be the most exciting adventure humanity has ever undertaken. The search for our cosmic neighbors is no longer just a dream. It is our new reality. How did we spot a possible city on a planet trillions of miles away? The answer: the James Webb Space Telescope and direct imaging spectroscopy. Webb's massive mirror collects faint infrared light, where artificial lighting shines brightest. Proxima B doesn't transit its star, so astronomers used a coronagraph to block the star's glare, isolating the planet's faint glow. Webb stared at Proxima Centauri for over 100 hours, capturing light from both its day and night sides. The shock: a localized spike in the infrared spectrum on the night side, consistent with artificial lighting. This wasn't a planet-wide glow, but a concentrated cluster of light sources. The level of detail from such a distance is a testament to JWST's engineering and the ingenuity of its scientists. We're no longer just inferring planets, we're dissecting their light for clues. Why is the scientific community so electrified? Because this isn't just another astronomical finding, it's a potential techno-signature. A techno-signature means evidence of technology, not just life. Artificial light is a profound indicator. On Earth, it marked a leap in civilization. If Webb has seen city lights on Proxima B, it suggests a species that's harnessed energy and built infrastructure. This is far beyond finding microbes. It's a sign of organized, capable life. The discovery energizes astrobiology, shifting it from theory to tangible targets. A techno-signature gives us a cosmic address to focus on. If we found one, there could be many more. Of course, skepticism remains. Extraordinary claims require extraordinary evidence. But the possibility alone ignites our imagination and validates decades of searching. This faint glimmer represents hope, that the great silence of the cosmos may soon be broken. The world is watching, captivated by the idea we may not be alone. To grasp the significance, we must understand Proxima Centauri B's bizarre nature. It orbits a dim red dwarf, huddling close to stay warm, completing a year in just 11.2 Earth days. The planet is likely tidally locked, one side in perpetual day, the other in endless night. The twilight Terminator zone might be habitable, but the detected lights are deep in the frozen night side. Why build cities there? Perhaps the day side is too dangerous, bombarded by stellar flares. Life may have evolved beneath ice, with advanced species building enclosed, artificially lit cities for protection. The lights could be the glow from these structures. Proxima B challenges our assumptions about where and how life could flourish. The search for life is a cosmic detective story with two main clues: biosignatures and technosignatures. Biosignatures are chemical hints of life, like oxygen and methane in a planet's atmosphere. On Earth, these gases are kept in balance by living organisms. Finding both on an exoplanet would strongly suggest biology at work. Technosignatures, however, are evidence of technology, like city lights, industrial pollutants, or artificial satellites. The glow on Proxima B is our first major technosignature candidate. While biosignatures hint at life, technosignatures point to civilization. It's the difference between finding a footprint and a sandcastle. That's why the search for technosignatures holds such profound promise. Proxima B's light could be the first sign of industry and purpose beyond Earth. This discovery stands on the shoulders of decades of tireless work by scientists searching for life beyond Earth. Their curiosity and determination have shaped our understanding of the cosmos, pushing the boundaries of what we know and what we dare to imagine. SETI began in the 1960s listening for deliberate messages from the stars but found only silence. Yet that silence was not discouraging. It was a call to innovate, to refine our methods, and to look for new ways to search for life. The discovery of exoplanets in the 1990s changed everything. Suddenly, we realized that planets are common throughout the galaxy, making the search for life a numbers game. Each new world became a potential home for life, and the odds seemed to tip in our favor. Kepler and TESS found thousands of worlds, revealing a universe teeming with possibilities. Now Webb takes the next step, not just finding planets but characterizing their atmospheres and searching for signs of life. Webb's mission is not just to count planets but to investigate them for biosignatures, evidence of life, and technosignatures, the telltale signs of technology and civilization. The Proxima B finding continues SETI's legacy but with a twist. Instead of listening for intentional messages, we're now detecting the unintentional byproducts of civilization, signals that might leak out as a result of daily life on another world. This passive SETI approach doesn't require aliens to want to be found, just for them to exist and to leave a mark on their environment. Civilizations can't easily hide the heat, light, and pollution they generate. These signatures can travel across the vastness of space, offering us clues to their presence. This approach may be more likely to succeed because it relies on the universal consequences of technology, not on the intentions of distant beings. The Proxima B signal is a milestone, built on the foundation of all the searches before it. Every experiment, every observation, has brought us closer to this moment. We're closer than ever to answering the question that has haunted humanity for generations. Are we alone in the universe? The search continues, more hopeful and determined than ever. As thrilling as this is, caution is vital. Science is full of false alarms, optical illusions, instrumental errors, natural phenomena. Proving the lights are artificial will be a monumental challenge. Every natural explanation, volcanism, chemiluminescence, reflective minerals, must be ruled out. Scientists must also ensure the signal isn't a telescope artifact, verifying data with independent teams. The signal must be robust, repeatable, and confirmed by multiple experts. More data is needed. Do the lights flicker, change, or show a spectral signature of artificial origin? Until then, the lights of Proxima B remain the most profound maybe in science. Proxima B is now the most intriguing target in the sky. Webb has reached its limits. Future telescopes must take us further. Next-generation ground telescopes like the ELT and GMT will offer unprecedented resolution, possibly mapping the light sources. Space-based successors like NASA's proposed Habitable Worlds Observatory will be optimized to find and analyze technosignatures. These missions could turn a faint glimmer into a recognizable map. The most ambitious idea, send a probe like Breakthrough Starshot's nanocraft to the Alpha Centauri system. A discovery of this magnitude could make such missions a reality. For the first time, we have a clear destination. The journey to understand Proxima B's lights will be carried forward by the machines of the future. We stand at a unique moment in history, a crossroads where the boundaries of science and imagination blur. Never before have we been so close to glimpsing the possibility of life beyond our own world. And the questions we face are as old as humanity itself. The faint light from Proxima B is more than a curiosity, it's a mirror for our hopes and fears, a distant signal that stirs our deepest wonder. It reminds us that the universe is vast, mysterious, and full of possibilities we are only beginning to imagine. If that light is ever confirmed to be artificial, It would mark a turning point for humanity, forcing us to confront profound questions about our place in the universe. Are we truly alone, or are we part of a much larger cosmic story? Such a discovery would challenge our sense of uniqueness and could foster a new sense of global unity, reminding us that, on this tiny planet, we are all connected by our shared curiosity and wonder. If a civilization thrives on Proxima B, it offers hope for our own future, and a warning. It suggests that life can endure, adapt, and perhaps even flourish under alien suns, but it also asks us to consider the challenges and dangers that come with progress. Why haven't they contacted us? Perhaps advanced civilizations learn to be quiet in a cosmic neighborhood whose rules we don't yet understand. Maybe silence is a form of wisdom, or a necessary caution in a universe filled with unknowns. Whether the lights are cities, volcanoes, or illusions, the search itself changes us. It drives us to develop new technologies, to ask bigger questions, and to look at ourselves with fresh eyes. It pushes the boundaries of knowledge and inspires new generations to dream, to explore, and to reach for answers that once seemed out of reach. Today, that world has a name: Proxima Centauri b. It is no longer just a point of light, but a destination for our curiosity and a symbol of our longing to connect with the unknown. As we point our telescopes at that distant glimmer, we're not just searching for aliens. We're searching for meaning, for connection, and for a sense of belonging in the vastness of space. Ultimately, we're searching for a new perspective on ourselves and our place in the cosmos. The journey has only just begun.